Welcome back to my today's session on magnetostatics. In my last session, I have discussed some important short questions on the Coulomb's law and the conductors and capacitors. In this today's lecture, I will discuss some magnetostatics, some important short questions. So while we are discussing about the magnetostatics, the first thing comes in the field. First, what is the field? I told in the last discussion also, field is a spatial area where we can measure any quantity. So field is basically, as we know, field is basically three types. First one is the electrostatic field. Then is the magnetostatic field or magnetic field. And the last one is the electromagnetic field. Electromagnetic field. Again, magnetic field is two types. First one is for the permanent magnet. And second one is for the electromagnet. Electromagnetic field means when the electric field and magnetic field superimposed on one another, we will tell the field as the electromagnetic field. And electromagnetic field is again two types. One is for the static electricity and another one is the time varying. So today's my topic is basically on the magnetic field only. Today we will discuss about the magnetic field only. So, what is magnetic field? We can define a magnetic field is a vector field that describes the magnetic influence on the moving electric charge, electric currents and magnetic material. A magnetic field is, first of all, it is a vector field. It has certain direction and describes the magnetic influence on the moving electric charge and moving electric current. So this will tell us about the Lorentz force and also the magnetic material. What is the meaning of magnetic material? Magnets and the ferromagnetic materials. So this is the magnetic field. In the magnetic field, a moving charge in a magnetic field experiences a force perpendicular to its own velocity to the magnetic field. So magnetic field, if any moving charge is there, then the force faced by the moving charge is equal to Q V cross B. What is B? B is nothing but the velocity and B is the magnetic field flux density, and the direction of F will be always in the perpendicular direction because it is a cross product, and we discussed in my last one video that if there is a cross product, the resultant is always use the right hand rule. So the formation, what is the direction formation of the field? The formation of the field is always north pole to south pole. Always, if we have a north pole and we have a south pole, the field is always starts from the north pole and it meets as the south pole. So the formation of the field is from north pole to south pole. The direction of the magnetic flux in a coil is always towards the right hand thumb rule, or we can tell it the right hand screw rule. Means if there is the magnetic flux in a coil, the direction always follows the right hand screw rule or right hand thumb rule. So this is the magnetic field. You can see if this is a magnet, if we have a north pole and south pole, the field will start from north pole and it will meet at the south pole. So this is the magnetic field. So define the magnetostatics. Magnetostatics is nothing but the study of the magnetic field developed by the constant current through the coil or due to the magnetic permanent magnet. As I told, magnetic field is two types. One is due to permanent magnet, or otherwise it is through the constant current. Magnetostatics is the study of the magnetic field developed by the constant current through the coil. When constant current flows through a coil, it turns into a static magnet or a permanent magnet. We are only magnetostatics. Statics means the magnetic field is constant, not the time varying. So, what are the difference between the magnetostatics and the electrostatics? So, we have the equation magnetostatics and electrostatics. First, if we think about the force of charge, if there is an electric charge is in an electric field, it will feel some force. F is equal to Q into E. This is the Coulomb's law. And if we think about the force in the permanent magnet, F is equal to Q V cross B. And if we add these two things, we will get the Lorentz force. What is Lorentz force? Lorentz force tells if there is a charge is moving in an electromagnetic field, it will feel two types of force. One is due to the electric charge, another one is due to the magnetic charge. And if we add these two, we will get the new force, which is Q E plus V cross V. Next, the field intensity. The field intensity we are writing by E. What is field intensity? If there is a if we keep one positive charge in a magnetic field, it will experience one force. It will feel one force, and this is known as the H. It is known as the E. E is the electrostatic field, and E is equal to epsilon Q by epsilon 4 pi r square. What is E? E is Q by epsilon 4 pi r square. Similarly, what is H? H is the field strength. If current flows through any coil, it will feel, if we keep on moving charge there, it will feel some force, and this is known as the H, or the magnetic field strength. And what is this? This is the Ni by L. N is equal to number of turns, I is equal to current, and L is the length. So the unit is E is equal to volt per meter, or we can write the unit as the unit can be written as the Newton per meter. So we can use the both unit, either it is Newton per meter, or we can tell it as the volt per meter. For the H, if we can write it ampere meter. Sometimes we write it by ampere turn by meter. So this is the unit of the H. What is the flux density? Flux density means flux per unit area. Electric flux per unit area is written by the D, and the unit is Coulomb per meter square, and is equal to psi by A, number of electric flux per unit area. What is the magnetic flux density? Magnetic flux density is equal to B. B is equal to phi by A. Flux per unit area, phi by A, and we can write it by Weber per meter square, or in one sentence, in one word we call it Tesla. So magnetic flux is written by Tesla. Then we will discuss about the magnetic relationship. We know D by E, the flux density by electric is equal to permittivity. Permittivity means epsilon is equal to again epsilon naught by epsilon r. Similarly, B by H is equal to mu, or permeability, and permeability is equal to mu naught into mu r. Then we can discuss about the energy storage capacity. For an electric field, the energy is stored in the capacitance, and for the inductance, energy is stored in the inductance. The source is the static charges. It is the steady state current. What is the source? If there is the static charge, we will tell it is the static charges are here, either steady current or DC current or the permanent magnet. So these are the main difference between the magnetostatics and electrostatics. Now, if we discuss the difference between the electric circuits and magnetic circuits, so we can write here electric circuits and we can write the magnetic circuits. So in the electric circuits, the main thing is the current I, or we can tell the charge Q, and here is Q is equal to always equals to electric flux psi. According to the Gauss law, Q is equals to the psi, and in the case of the magnetic circuits, we will write it by B. B is the, we can write it by the phi. What is phi? Phi is equal to magnetic flux. So in the flux, we are telling flux is equal to psi, here phi. What is the unit of psi? Psi unit is coulomb. What is the unit of phi? The unit of phi is the Weber. Next, we will discuss about the intensity. In the case of the electric circuits, intensity is written by E is equal to Q by 4 pi epsilon R square. Here we write, and the unit is Newton per meter, or we can write volt per meter. But in the case of the H, the unit is always H is equal to Ni by R or L, and the unit is ampere turn per meter. Sometimes we write, if number of turns equals to 1, we write it ampere turn. Next, we can compare the resistive property, and here we can write R is equal to rho L by A. Here we can write the reluctance, and reluctance is the resistance, and this is the reluctance. Reluctance is equal to 1 by mu L by A. Next is in the case of the magnetic circuits, the current will flow, but in the case of the magnetic circuits, the flux will flow. So these are the basic difference of the electric circuits and the magnetic circuits. Name the laws used in the magnetostatics. They are like electrostatics based on the two basic laws. One is the Coulomb's law, one is the Gauss law. Similarly, the magnetostatics has been on two laws. The laws are the basically tells about the behavior of the magnetic field, and it is added by the two laws. One is the biosuberts law, one is the Ampere circuital law. In the biosuberts law, H is equal to ideal sin theta by 4 pi r square. We can write H is equal to integration I dl cross AR by 4 pi r square. So this is the biosuberts law, that the field intensity, if there is a current carrying conductor, the field intensity in a distant point depends on the dl cross AR by 4 pi r square. What is the Ampere circuital law tells? Ampere circuital law tells, if there is a current is flowing in a conductor, that there will be a electric flux, and the electric flux inside the conductor H dot dl is nothing but the I enclosed. And in the vector form also, we can write grad cross H is equal to J plus d by d into dt, where J is the current or conduction current density, and d by dt is nothing but the, what is d by dt? D by dt is the displacement current density. So we can discuss these two rules. Next, Define the magnetic flux density. Whenever there is a current flows through a coil, there will be a generation of the magnetic flux, and the magnetic flux density can be defined as the magnetic flux per unit area. The magnetic flux density can be defined as the flux per unit area, and B is equal to d phi by ds. The unit of B is Weber per meter square, and in any one word we can call it the Tesla. So what is d phi? D phi is equal to B ds, and phi is equal to integration of B ds. Explain the magnetic field intensity. So what is the magnetic field intensity? The degree to which a magnetic field can magnetize a substance, or capability of external magnetic field to magnetize the substance, is called the magnetic intensity. So what is the magnetic intensity? The degree, the power to which the magnetic field can magnetize a substance, or the capability of external magnetic field to magnetize the substance, is called the magnetic intensity. The force experienced by the coil when the current flow passes through it is called the H is equal to Ni by L. H is equal to Ni by L. What is the unit? Unit is nothing but the ampere turn per meter. Next, define the magnetic susceptibility. In the electromagnetism, magnetic susceptibility, generally denoted by the Xi, this sign is Xi. This sign is known as the Xi, is a measure of how much material will become magnetized if we keep an applied magnetic field. I am giving one simple example that if we are taking any iron coil, there are some the atoms are in that different direction. But when we keep the iron in a magnetic field, or if we give one DC current DC in it, it will be in a proper direction. It will be in a proper direction. So this depends on the amount of current, as well as it depends on the material property. So in the electromagnetism, the magnetic susceptibility is a measure of how much a material will become magnetized in an applied magnetic field. It is the ratio of magnetization M to the applied magnetizing field H. So we can write K is equal to I into H. Total flux density B is equal to B due to magnetic field plus B due to the intensity of the magnetization bar. So we can write B is equal to mu naught H plus I. So this is the magneto. Next, explain the permeability of the core. Permeability is the inherent property of the core which helps in sustaining the flux in the core. Permeability is the inherent property of the core. All the cores have some permeability. So permeability is the inherent property of the core which helps in sustaining the flux in the core. Core will not go outside. So like iron has a very good permeability, whereas wood permeability is very less. So permeability can be defined as the ratio of the flux density to the flux field intensity. Permeability, again like the permittivity, permeability is also two types. One is the absolute permeability or permeability of air, written by the permeability of the free space or vacuum, or normal vacuum, is known as the absolute permeability. It is written by mu naught and value is 4 pi into 10 to the power minus 7. Similarly, what is the relative permeability? Relative permeability is equal to mu r. Mu r is equal to permeability of a medium with respect to the relative permeability is with respect to the absolute permeability. And what is the permeability mu? Mu is equal to mu r into mu naught. Explain the intensity of the magnetization. So when a magnetic substance is placed in a magnetic field, it experiences a magnetic momentum. The magnetic momentum per unit volume of the substance is known as the intensity of magnetization, not magnetic field intensity. Both are totally different. Magnetic field intensity is H, and H is equal to Ni by R, the property of any field to experience some force. But what is the magnetization? Intensity of magnetization. When a magnetic substance is placed in a magnetic field, what will happen? It will be changed into the magnet, and it experiences some magnetic momentum. Magnetic momentum means the atoms in this magnetic substance will change its position from any position. It will try to arrange itself in the north-south direction. So it will experience a magnetic momentum, and magnetic momentum per unit volume is known as the intensity of magnetization. So classify the magnetic material according to the permeability. Actually, according to the permeability, there are three types of the magnetic material: ferromagnetic, diamagnetic, and another one is the non-magnetic material. So what is the meaning of the ferromagnetic? So ferromagnetic, as the name suggests, it is a ferro group, means iron group things. You know the Fe group is the iron group things, and the mu, or the relative permeability, is much greater than 1. Ferromagnetism is a basic mechanism by which certain materials from permanent magnets are attached to the magnets. So ferromagnetism is a basic mechanism. This is the basic mechanism of the magnetic material, so that by which certain materials from permanent magnets are attracted to the magnets. Certain materials like iron, cobalt, nickel, they will be changed into the materials to the permanent magnets, or it can attracted by the magnet. If we keep one magnet and we keep one iron bar, it will be attracted immediately. What is the meaning of the diamagnetic material? As the name suggests, diamagnetic material are repelled by a magnetic field, and magnetic field creates an induced magnetic field in them which is opposite in direction and causing a repulsive force. So it is not a permanent magnet. What is the property? Whenever it will comes near a magnetic field, in the field there is another magnetic field of opposite polarity will be induced, and that's why the magnetic field always gives a repulsive force to it. So this special property of this material is known as the diamagnetic material. So diamagnetic material are the property from where it can feel some force. So what are the examples of the diamagnetic material? The diamagnetic materials are copper, gold, antimony, silver, lead, and hydrogen. And as we can understood, it is in the opposite direction. The relative permeability is always less than 1. The relative permeability is always less than 1. So it has a very less relative permeability value. What is the meaning of the non-magnetic material? As the name suggests, the non-magnetic material is equal to mu r equals to 0. So non-magnetic materials do not get attached to a magnet. If we keep it in a magnetic field, or we bring the non-magnetic material near a magnet, it will neither change into the magnet nor it get attached to a magnet. So this is known as the non-magnetic material. So for it, mu r equals to 0. And what are the example of the non-magnetic material? The non-magnetic materials are wood, plastic, clothes. So these are the example of the non-magnetic material. Now State and explain the importance of the biosuberts law. So what is biosuberts law? The magnetic field intensity due to an current element IDL is equal to DH, and according to the biosuberts law, DH is directly proportional to IDL. DH is directly proportional to sin theta. What is sin theta? Angle between the current element and length joining point. And DH is inversely proportional to the 1 by r square. So if we take these three equations at a time, we can, by combining these three, we can write DH is directly proportional to IDL sin theta by r square. So if this is a current carrying conductor, we are calculating the DH at a P, and this distance is r. The current flowing through this small dl is the I. Then we can write H at P is equal to DH is directly proportional to the IDL sin theta by r squared. So if we remove the proportionality constant, we will get DH is equal to IDL sin theta by 4 pi r square. So this is the DH. So total magnetic field H is equal to integration in a closed path IDL sin theta by 4 pi r square. What is B? B is equal to mu IDL sin theta by 4 pi r square, as B is equal to mu H. Next question is what is the meaning of the superconductor? The superconductor is a material that offers no resistance to flow of electrons and electricity. What is superconductor? Superconductor is a material that offers no resistance to the flow of electrons and conducts electricity. The superconductivity phenomena was discovered by first Omens, the Dutch physicist, in the year of 1911. In the 1911, in the lab, he first made the superconductors. Superconductors are elements or metallic alloy. It is not like any metal, it is a metallic alloy. And when it is cooled below a certain threshold temperature, it loses its resistance property and become the superconductor. Superconductor means the resistance value is very, very low and it is almost equals to 0. So it becomes under a certain threshold temperature. If we cool down, if we decreasing the temperature of the laboratory, and at a certain temperature, certain threshold temperature only, it can lose the electric resistance property and become the superconductors. Some of the superconductors are niobium, cuprate, magnesium, diboride. So these are the some superconductors. Next, write the expression for magnetic field intensity due to infinite state conductor. So for this, we know H is equal to IDL cross AR 4 pi r square. So for this is a long conductor, and we can calculate from here that we have to calculate the DL cross AR. So if it is the height is 0, 0, Z, and this is the height is, this distance is R, means if the distance is small r and the value is R 0, 0, so the position vector of this point is RAR and the position vector of this is ZAZ. So what is the distance R? What is the meaning of the distance? End point minus starting point. So the equation of the hypernet OP line is equal to ZAZ end point minus, so RAR minus ZAZ. And what is the value of the AR? AR is nothing but the, what is the value of the AR? AR value is we can get from the distance. So this is our R value. This is our R value. What is R? R is equal to RAR minus ZAZ. So if we calculate the DL is nothing but the Z. So if we calculate the DL cross AR, what is AR then? AR is equal to R. What is R? R by mod of R. What is R? RAR minus ZAZ by root of R square plus Z square. So if we want, we can calculate the value of the DL cross AR, A phi, AZ. So R, so DL cross, so what is R? R minus Z, 0, 0, Z. So, sorry. So if we calculate, this is R, 0, 0. So if we do the cross multiplication, we will get integration of I R dz A phi. So you can see minus of R z, R dz, not z, R dz A phi. So if we take the z is equal to sec theta, as in dz is equal to sec square theta. So what will happen then? Then we can, for infinitely long conductor, z is equal to minus infinity, so theta is equal to minus pi by 2. Z is equal to infinity, so theta is equal to pi by 2. So if we solve it, we will get h is equal to I by 2 pi r A phi. Next, write the analogous of the Gauss law in the magnetostatics. It is similar to the Maxwell's second law, or we can tell these are same questions to the Maxwell's second law in or modified Gauss law in the magnetostatics. From the Gauss law, we can write that the magnetic flux in a given surface is equal to the surface integral of the magnetic flux density. But in the Gauss law, magnetism tells the magnetic flux across any closed surface is 0. Because magnetic flux never confined in a closed surface. So this is the, we can write that V magnetic flux density dot ds is nothing but the 0, and we can write it like if we use the divergence theorem, grad dot v dv is equal to 0. So this is the Maxwell's second equation in integral form. And from here we can write grad dot v is equal to 0. This is the Maxwell's second equation in point form. So we got the Gauss law in magnetostatics, or we can write this is the Maxwell's second equation. Now state the Ampere circuital law. Ampere circuital law states that the line integral of the magnetic field intensity around any closed path is equal to the total current enclosed in the path. So we can write H dot dl is equal to I. Write the applications of the Ampere circuital law. The machines can be motor, generator, transformer, any type of machines or other similar devices can always follow the Ampere circuital law. All the works follows the principle of the Ampere circuital law. Extract the expression for the Maxwell's second equation. So already we have discussed the Gauss law, analogous Gauss law. So same thing from the Gauss law, we can write the magnetic flux density psi is equal to B dot ds. So total flux density in a closed surface is equals to 0. So psi equals to B dot ds equals to 0. So B dot ds can be again rewrite at grad dot b, and grad dot b is the Maxwell's second equation in point form. And this equation we can write the Maxwell's second equation in integral form. So these are the Maxwell's important equation of the Maxwell's. Extract the relationship between the B, H, I and L. So one by one I will discuss. What is B? B is known as the flux density. And what is flux density? Flux density is equal to phi by A. What is H? H is equal to field intensity. So we can write what is H? Ni by L. Ni by L. L is the length of the line. So what is the relation between B and H? The B and H relation is equal to B is equal to, we know, mu into H, or mu is equal to permeability of the medium. So this is the relation between, here we take the capital L, here L is nothing but the length, not the inductance. Here L is the length, not the inductance. So B is equal to mu H. What is the unit of B? Weber per meter square. What is the definite unit of the H? Ampere ton per meter. And using the BH-IL relationship, or we can tell using the BH relationship, we get the hysteresis loop. If we take the H in the x-axis and we are taking the B in the y-axis. Now, if we increase the H, how we can increase the H? Either increasing the number of turns or increasing the number of current. So, if we increase the number of current, the flux density will increase. B will increase because B is equal to mu into H. But after certain time, it will be in a constant mode. It will be in a constant mode. Now, if we start to decrease H, if we now start to decrease H, what will happen? It will come up to this. It will not follow the same path. It will come back in the different path, and when you can see H is equal to 0, B has a certain value. B has a certain value. Again, we are decreasing the H more. So, when the H has a certain negative value, B may be 0. So, if we draw like this, we will get this type of curve. We will get this type of curve. So, this curve is known as the hysteresis curve, or known as the BH curve. Interpret the expression of the magnetic field intensity of the circular path. So, from the biosuberts law of the magnetic field intensity at center point P due to current element, we can write if the current is IDL, DH is equal to IDL sin 90 degree by 4 pi r square. Actually, from the biosuberts law, we got DH is equal to IDL sin theta by 4 pi r square. Here the angle for a circular path is always 90 degree. So sin 90 is equal to 1. So we can write DH is equal to IDL 4 pi r square. So if we integrate both sides, I is constant, DL by 4 pi r square. For a circular path, the length of a circle is nothing but the 2 pi r. Nothing but the 2 pi r. So H is equal to I 2 pi r by 4 pi r square, and H is equal to I by 2 r. H is equal to I by 2 r. Next is the interpret the Maxwell's third equation. So from the Ampere circuital law, we got the H dot dl is equal to I, and again we know that if J is the current density, then integration of J ds is equal to I. So H dl is equal to J ds. We can also write H dl is equal to grad cross H ds. So if we equate the two sides, we can, so this is our integral formed. Now if we equate the two sides, we will get grad cross H ds is equal to J ds. So grad cross H is equal to J, and this is the Maxwell's third equation. If we go for the modified Maxwell's third equation, that grad cross H is equal to J conduction current density plus Jc, because when current is flowing through a conductor, there is some leakage current. So grad cross H is equal to J plus Jc. Jc is nothing but the displacement current, and we can write J is equal to dD by dt. This is the Maxwell's third equation. So there is one small problem. A current of 1 ampere is flowing in a circular coil of 10 centimeter and 20 tons. Calculate the field intensity and the magnetic field of at a distance of 10 centimeter on the axis of the coil and the center. So we got that the for 1 ton H is equal to I by 2R. We just got for a circular coil. So if it is a number of turns is N, so we got Ni by 2R. So N is given 20 turns, I is given 1 ampere by 2R. R is given here the 10 centimeter. So we will get the value 100 ampere turn per meter. So this is my today's class. We have discussed some short questions which are for the 2 marks question for this chapter. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.